Good, how about you?
Okay. Okay, let's see. Is this the document you sent me last time?
Yeah, but I'm working on something way different now.
Okay.
One moment.
Can you verbalize it, or do you need to send it to me?
I'd rather send it to you. It'll be a lot better that way.
Yeah, go ahead. You have my,
Okay,
if you type DA, should pull up my David Cowan 1949 email address.
Okay.
What kind of stuff are you working on now?
Right now I'm working on parent graphs and transformations.
Okay.
Okay, I just sent it.
Okay. I got it. Oh, no, I didn't get it. Not yet. There it is. And let's see. This is the only one that matters, is it not? Okay. What's the parent graph of 1?
Would it be x squared?
Okay. What's being done to it?
It's
What's the translation? What's the transformation?
down 1.
Okay. So the parent graph would look like this. That's what y equal x squared looks like.
Yes.
I don't change the shape of the graph, as all I do is vertically move it down 1. So it looks exactly the same, only its vertex goes through that point.
Okay. So I could use a graphing calculator for this, right?
No, I'm sure it says you may use your graphing calculator to compare to make sure they're the same. But
Okay.
the concept of this whole thing is to be able to do it based on your knowledge of how to graph the parent function and then what is being done to the parent function. In other words, as long as you know how to draw g of x equal x squared, and you know that it's a vertical shift down by 1 unit, then you don't need a graphing calculator. And I'm sure they want you to do this part without a graphing calculator. It says you may use one just to kind of verify that you're right. Second one, what's the parent function?
X.
Well, let's give it as, in fact, let's call it y.
Okay.
What's the parent function?
How do I actually find the parent function, to be honest?
It's right there. In other words, you have only learned like 9 or 10 parent functions. Okay.
Mm-hmm.
One of them is y equal mx plus b. The other is y equal x squared. The other is y equal x cubed. The other is y equal absolute value of x. The other is y equal sine x. The other is y equal square root of x. These are the parent functions.
Okay.
So when you see something like this, if you know what the parent function looks like, and you know what all the other numbers are doing, in other words, what they represent, then you can graph the regular function. Now, I think it's particularly important to take you through this analysis. Notice that each of these functions is not y equals, it's g of x or f of x. Okay?
Mm-hmm.
Let's talk about this function right here. Okay?
Yes.
If there are 6 things you can do to functions, and they all have to do with what you're doing to f of x. So if I want to add a number, I want to make sure I write this properly. If I want to add some number to f of x, like that, that gives me that. That is a vertical shift. If c is positive, it's up. If c is negative, it's down.
Okay.
If I have the following, and if I lose you here, please say something, because this is a little tricky. That is a horizontal shift. And what would that look like? In other words, what does it mean when I say f of x minus c if f of x equals, what is f of x minus c equal?
F of x minus c. Would that be...
Let's start from the beginning. What's f of 2 equal to? If f of x equals x cubed, what is f of 2 equal?
F of x equals x cubed. So then...
What would f of 2 equal?
4?
No, it'd be 2 cubed, right?
Oh, 2 cubed, yeah, then that, okay, never mind. Now I see what you mean.
Okay, so the thing is that whatever is in the parentheses, you just plug in for x.
So I just plug in the number for x.
Yeah.
Okay.
Whatever it is, whether it's a variable or a number. If I said, what is f of y? Well, then that would be y cubed. If I say, what is f of x minus c? Then that is x minus c quantity cubed. You with me?
Yes.
Okay. These are the 2 shifts that you can do. There's also stretches. If we want to do a vertical stretch or shrink, you get that by putting the number in front of the function. Notice the difference in each of these. This is f of x plus c. This is f of the quantity x minus c. This is c times f of x. So that would be c times f of x. In other words, if I said, what is 3 f of x? 3 times x cubed.
And so that would be, so 3 cubed times 3.
No. 3 times whatever. Remember, x is a variable.
Okay.
So this, what you're going to need to be able to do when you're all done here is look at this and figure out, is that a vertical shift, a horizontal shift, a vertical stretch, or a horizontal stretch? That's going to be the name of the game. So that's why it's important that I go through this. Now let me finish it, because there's only a few more things you can do, and then we'll talk about each situation. The other thing is a horizontal stretch. And remember, stretches and shrinks change the shape of the curve. You get a horizontal stretch by putting the number inside the parentheses.
And then when it's outside, it's vertical.
Correct. When it's inside, it's horizontal. These
Yeah.
are the four primary. In other words, this would result in, if C was 3, putting everything in the parentheses. In other words, if I said f of x is x cubed, and then I said, well, what is f of 3x? It would be the quantity 3x cubed. With me?
Yes.
There's only two more things that can be done. One is a reflection over x, and you get that with a minus f of x, or in our case, minus x cubed. And the last thing you can do is a reflection over y axis, and you get that by f of minus x. So that would be minus x quantity cubed. So make sure you understand what we're doing in each of these. Starting with a parent function, no matter what it is, if you take that parent function and add a constant to it, that's a vertical shift. In other words, when we had x squared plus 1, our parent function was x squared. Well, x squared plus 1 is a vertical shift of 1 unit, correct?
Mm-hmm.
So if I said to you, what is this? What is that? That's x squared, only there's a transformation happening to it. What is the transformation?
Moving 3 horizontally. Would it be to the left?
To the right. In other
Oh, so it's the opposite. Okay.
It's a positive number, and in this case, it's a positive number. Notice that the standard is x minus c. So
Yes.
in our case, c would be a positive 3, which means move to the right.
Right.
That would look like, instead of this, I'm going to move it over 3 units to the right. Again, no change in shape, only a shift. That's why this is called a vertical shift, and this is called a horizontal shift.
Okay.
Okay? This may seem unnecessary, but I guarantee you that it's necessary to go through each of these. If I want to do a vertical stretch, let's say I had 5x squared. Well, notice that if I look back, that fits that model. So this is a vertical stretch. If I'm going to plot that, instead of looking like x squared, it's going to stretch it, make it skinnier by a factor of 5. So when you have vertical stretches or shrinks, it does change the shape of the graph. Now, if I said, well, what is a half times x squared? That flattens it. In other words, the number 1 is key. If this number, if c is greater than 1, it makes it skinnier. If it's between 0 and 1, it makes it flatter.
Okay.
Okay. Horizontal shrink is similar. Only with a horizontal shrink, the c is inside the parentheses. So if I said to you, what is 9x squared? In other words, if I gave you this function, g of x is equal to 9 of x squared, what's going on to that? You could say two things. You could say I have a vertical stretch factor by a factor of 9, correct?
Yes.
Or I could write that as quantity 3x squared. Now I have a horizontal scrunch factor by a factor of 3. So vertical stretches frequently look like horizontal shrinks. Now, here's the thing to know. If this number, if we're doing a vertical stretch, if it's greater than 1, it skinifies it. In this format, when we're doing a horizontal stretch or shrink, if this number is greater than 1, it shrinks it. It pushes it together. In other words, if I'm going to take my parabola and I'm going to shrink it horizontally, I'm going to push from that side, and I end up getting a skinnier parabola. So horizontal shrinks tend to be the same as vertical stretches, at least in the way they change the shape of the curve.
Okay.
Okay. That covers the main 4, and the other 2 are relatively easy because they're just reflections. Well, if I said to you y equals minus x squared, parent function is x squared, the only thing that's happening is I have a minus sign in front of the function, makes it a vertical reflection over the x-axis. So that's what it looks like. Okay, when the minus sign is in front of the function, vertical reflection over the x-axis. If the minus sign is within the function, like the very last one here. In other words, if I said, well, what does this look like? Notice that the minus sign, I'm now taking f of minus x, not f of x, and this is a reflection over the y-axis. Well, if I take my basic thing and I reflect it over the y-axis, what does it look like?
It looks like it's gonna
Same thing.
be like it's symmetrical.
Exactly.
Yeah.
So it won't change it. In other words, if I take this graph and I reflect it over the y-axis, it does not change it. And sure enough, when I square this, I get the same function. So putting the negative sign inside doesn't change it for this function. For this function, it actually does. For the x cubed function. Let's look at that for a moment. In other words, if I said, what's going on to this? You would say, well, that's a reflection about the y-axis. Well, what does the parent function looks like? The parent function looks like that. Well, if I reflect that about the y-axis, I get that. And that is y equal minus x cubed. And notice that with x cubed, f of minus x is the same as minus f of x. In other words, this could be either a reflection across the y-axis or a reflection over the x-axis. Either one fits.
Okay.
All right, so don't want to leave it yet. I know you're anxious to get to your problems, but I want to make sure that you can go backwards on these. So our parent function is going to be x squared. What I'm going to give you are a number of functions, and I want you to tell me what's going on with it.
Okay.
So if I gave you y equals x squared plus 5, what are we doing?
It's going to move up 5 from the parent function of x squared.
Vertical shift of plus 5. If I say y equals minus 5x squared, two things are happening. What are they?
I believe I'd be moving to the right 5, correct?
No? In other words, you have to be able to look at that and figure out which of these things that is. Well, it's this thing at the bottom, reflection over x-axis, because I got a negative sign in front of the function.
Oh yeah, so it
And
reflects.
the 5 is a multiplier, so it's this situation also. So I have two things. I have a reflection over the x-axis, and I have
And multiplied by 5.
a stretch factor by a factor of 5. So the way I'm going to graph that is like that, instead of the parent function, which is like that.
Okay.
Okay? This is the hard part here, is where they give you the function and they say, graph it based on what you know is going on. Okay, we're not. Here I have three things going on. Three transformations. What are they? Define them for me based on my stuff on the left.
So
We'll start from there. What is that 5?
multiplying by 5.
So what is that? What type of transformation is that?
That'll be a stretch.
Vertical stretch.
Vertical stretch.
Because we also have horizontal stretches, so you have to distinguish between them.
Okay.
What's this doing?
That's moving it to the left 3.
To the right.
To the right. How can I tell the difference on which way it moves?
Because you have to memorize this. In other words, the standard is f of x minus c, and if c is positive, we go to the right. If c is negative, we go to the left.
Okay.
And that's pretty easy to remember because most math, to the right is positive, to the left is negative.
Yes.
And most functions are x minus. Whether you're dealing with the standard vertex format for a quadratic, it's x minus h, right?
Yes.
If you're dealing with conic sections, it's y minus h plus y minus k. Maybe you haven't gotten to conic sections yet, but most everything is minus. So when you're memorizing these things, know that it's usually minus if you're talking inside the parentheses.
Okay.
And what was, I can't remember what I had there. I had y equal 5 times x minus 3 quantity squared plus 4. What's the constant? So we know that's a vertical stretch factor by a factor of 4.
Yes.
That's a horizontal shift to the right by 3 units. What's this?
And vertical shift up by 4 units.
Okay. So now I'm going to give you one that has everything. Are you familiar with the e to the x function?
No.
You haven't been taught that basic function?
I've seen it before, but it's been a really long time.
Okay, we'll use x squared. Now I'm going to give you one that's got all 6 things going on. Excuse me. So I got 2 reflections. I don't have a horizontal shift or scrunch in there, but I got 5 things going on here. In fact, let me not make it this complicated because that is a little confusing actually. So here we got 4 things going on. Let's make it harder. Let's make that a fraction, less than 1, with the sign. What four things do I have going on here? Start from left and go to the right.
Okay, well, I see that it's gonna be a reciprocal
Reflection.
or a reflection.
Over which axis? Because there's two axes to reflect over?
I believe it's a horizontal.
Yes, the x-axis. What's the effect of the 1/3?
The 1/3 is affecting it's a horizontal stretch, right?
It's in front of the function, right? So
Okay.
if it's this, that c is not inside the function.
Okay.
That c is in front of the function. If the function is x squared, when I put that minus 1/3 parentheses, that's in front of the function. So that is vertical shrink.
Okay.
In other words, instead of the parabola looking like that, it's going to flatten it out. That's what vertical shrinks do.
And it shrinks whenever it's not a whole number?
No, only if it's between 0 and 1.
Okay.
1 is a very important number here. If it's greater than 1, it's a stretch. If it's between 0 and 1, it's a shrink. What is it if it's minus 2?
That would be, wait, 0 and 1. Would that be a
stretch? That's a stretch because the absolute value of the number is greater than 1. In other words, the negative sign is the reflection over the x-axis. The 2 is a vertical stretch. So the only time you have vertical shrinks are when you have a number between 0 and 1 right there.
Okay.
What's the consequence of that plus 1 inside the parentheses?
The plus 1 will, I believe that will make a horizontal shift.
Which way?
So since it's a plus, it will be to the right.
To the left. In other words, that means
once it gets in the function,
c is equal to minus 1, right?
Yes.
Because I'm looking at this as my standard. What is f of x minus c? Well, I've got x plus 1, therefore c has to be minus 1. Minus means left.
Okay.
And finally, what's the plus 4?
Shift upwards 4 units.
Vertical, yes, that's fine. Okay. Those are the 6 transformations. Now, I realized I knew I was going to spend the entire half hour going over that, but that's how important I think that is.
Okay. So I can understand it for the rest.
Yeah, and see, what you are always given is the transformed function. So you always have to take this transformed function and figure out what's happening to it. What's my elementary function on 2?
The absolute value of x.
Correct. So y equals absolute, and you should know how all of these elementary functions graph. That's what that looks like.
Okay.
What 2 things are happening to it? With what transformations? In other words, the parent function is going to be y equals absolute value x, but the transformations you have to list. You got 2 of them.
Yes.
What are they going to be?
2 will be a horizontal stretch.
No, it's a vertical.
Yikes. Okay.
Outside the function, right? The function is the absolute value of x. If it was inside the function, it would be the absolute value of 2x. But since that 2 is outside it, it's got to be a vertical stretch. So your answer, vertical stretch by factor of 2. That's the first transformation. That's what you want to write right there. What else is going on?
Then I see a -1.
What is
which is inside the function.
What's that? Okay, so what does that become?
So it would be x minus c, which is -1. So would that be a horizontal shift?
Correct. Which way?
Um, since it's a negative and a negative, would that make it a positive?
Well, yeah. In other words, C is +1, right?
Yes.
Since that's my standard, x minus c, well, I'm looking at x minus 1, therefore c has to be 1.
Okay.
C is positive, positive's to the right.
Yes.
So that is a horizontal shift to the right.
To the right. Wait, so could I do it that way? Like see that it's a negative and a negative in the formula, and then
Yeah, it's
make
going to
my...
come out the same. So I don't really care how you do it. What it's going to look like is the vertical stretch going to cause it to look like that, right?
Yes.
Shifting it 1 to the right is going to cause it to look that same exact shape that I just drew, only the vertex is now at right there. So to graph this, that's what it would look like. Now, one last thing, very, very important. Always do your reflections first. If you don't do them first, you will end up with a wrong-looking graph.
Okay.
Okay? If I'm going to graph this, I will get a different looking graph if I do the vertical and the horizontal shifts first and then the reflection. I have to do the reflection first and then do my shifts or stretches. And that includes all reflections. If I have a reflection that I'm going to reflect over the y-axis, then I have to do it first. It doesn't matter which reflection you do first if you have 2 reflections to do. Just do all reflections first. You'll never get it wrong.
Okay.
Okay? You good to go, or you want me to look at one more of these just to make sure you got it?
I think I'm good. Thank you, though.
Okay.
Okay, have a good day.
You too, Taylor. Talk to you next time.
Okay, sounds good. Bye.